circles on the graph. So you're going to be able to write an equation for a circle. You're going to be able to look at the equation of a circle and find the center and the radius, and graph the circle on the coordinate plane. The equation of a circle was derived using the distance formula. So if you look up here on your paper, I have this circle on the graph. The center is at HK. I don't know for sure where it's at, so we're just going to say H and K. I don't know why they pick H and K. Every geometry book says the center of a circle is H and K, which is something they all use. XY is just a point on the circle. What does R represent? The radius. We need to find the length of the radius. To find the length of something, you find the distance between its two endpoints. That's why we're going to use the distance formula. Do you remember the distance formula? X2 minus X1. Touche. That is. Is it? Distance equals rate times time? I think that's right. Keep going, Spence. Y2. Okay, we're missing a couple things. And then the square root of all that. Good. That's your distance formula. So if you don't have it written down, write it somewhere, maybe at the top or something. We didn't use it a bunch this semester. We used it a lot first semester. You'll see it on Thursday on the review, and you'll see it on Friday at the end of the year test. So it's kind of a nice review here. I'm going to call my center my x1 and my y1 values. And then I'll call this other point on the circle x2 and y2. And then we're going to substitute them into the distance formula. The distance between those points are going to give us the length of the radius. So I can just start off by saying r equals, because we're going to find the length of the radius there. Which value should I plug in for x2? Minus, what's my x1? Quantity squared, plus, what's y2? Minus my y1. Good, quantity squared. This would give you the length of your radius. So if I actually gave you numerical values, you'd be able to find the length of the radius doing this. You wouldn't be able to count it because it's at a diagonal line, so you'd have to use your distance formula. How could I get rid of this square root symbol on the right side? It's the inverse of square rooting something. Square it. I'm going to square both sides. On the left side, that's just going to be r squared. Ooh. And then on the right side, the square root and the square cancel each other out, so then you're left with x minus h quantity squared plus y minus k quantity squared. This is the equation of a circle. It's already typed out for you as well. But some person derived this equation. They looked at circles on the graph, used the distance formula to find the radius, and this pattern showed up at each time. H and K, this is also typed out on there, represent the x and the y values of your center point. And then R is going to be your radius. So it's going to be in the equation as r squared. You're going to have to take the square root of the end part to figure out what the radius is. Show you how it works. If I just say that the center of a circle is at 3, 2, and I'll tell you the radius is 5. If I give you that information, that's enough. All you need is the center and the radius to write the equation. You're going to substitute in for R, H, and K. So my H value is the X value of the center. Is that 3, 2, or 5? 3. The K value is the Y value of the center, which is, and then 5 is my R, my radius. Take those 3 points and just replace them up here. I'm just going to flip it around and start with X minus. So X minus, what should I put in there instead of an H? 3. Quantity squared plus Y minus, then what should I put in? 2. Quantity squared equals my R, which is 5, and then squared. So I just changed those 3 values. You're not going to do anything else here. I can't subtract 3 from x. You don't substitute or distribute that 2 in. You just leave it. So it's just x minus 3 squared. Same with the y value. Can't do anything more with that. I can simplify that. What is 5 squared? So this would be the equation of a circle that has a center 3, 2, and a radius of 5. Which brings us to example 1. This is write in standard form the equation of a circle with a center negative 8, 0, and a radius of the square root of 5. You're going to take those three values and substitute them into your standard equation. Oop, gotta hit the freeze button. All right. So negative 8, 0 into the square root of 5. The negative 8 represents which of mine, h, k, or r? How about 0 and the square root of 5? All right, so when I plug them in, x minus, what's my h value? Negative 8 quantity squared plus y minus, what's my k value? 0 quantity squared equals, what's my r value? Square root of 5 quantity squared. Then you have to see if you can clean them up at all. X minus negative 8 Spence becomes what? Becomes x plus 8. Y minus 0, you can leave it as y minus 0, but y minus 0 would just be y, so you could also just write y squared, it wouldn't matter. And then what's the square root of 5 squared? The square root of 25 is 5, good. So this is the equation of that circle. Because it's subtraction in the original equation, your signs are actually going to be opposite of what the center is. If it's at a negative value, then it becomes plus in here because you're subtracting a negative. If it's at a positive value, then it'll stay minus in here. Questions? Okay, flip it over. I want you to practice this again on the other side, and there's 2 of them right below the big graph where you have to write the equation. You got center at 3, 5, and a radius of 6, and then do it again with the other one right next to it. Write in standard form the equation of a circle with center 5, 8, and passes through the point negative 15, negative 13. Okay, so it's kind of like the very first one we did, and then the 2 on the back. In order to write the equation of a circle, what do we need to know? Good, radius and center. Well, we know our center, it's at 5, 8. Brian? Okay, how are we going to find the diameter? Okay, between what 2 points? Okay, so if I graph this, my center is going to be in quadrant 1, right? And my random point on the circle, negative 15, 13, that's going to be over here in quadrant 3, you agree? Okay, so if I connect them, Brian, what's that segment representing on the circle? Above what, though? Like, what is that in relation to the circle? Why is it the diameter? Yeah, but what's this point? Isn't that the center? So is this line going all the way across the circle or just halfway? So wouldn't this be our radius? Yeah. But you are right. What do I have to use to find the length of it? Distance formula. Do it. You have the distance formula written at the top. Find the distance between, well, I'm calling them P and C here, to find the length of your radius. Okay. I don't know, x1, y1, x2, y2. So then the length of our radius using the distance formula, negative 15 minus 5 quantity squared, negative 13 minus 8 quantity squared. What's negative 20 squared? 400. What's negative 21 squared? Remember, guys, 12 squared is 144. 21 squared is 441. Remember our pattern? You see it, Bracy? Yeah. Okay. That's cool. Square root of 841, so what's the radius? 29. Okay, so you've got your radius. And you have the center already, so now you're going to take 5, 8, and 29 and plug them into the equation, because you're not done. Because you don't have to find just the radius, now you have to plug it in like we did the one above it, where you substitute them into the standard form. X minus h quantity squared plus y minus k quantity squared equals r squared. What should we put in for h? How about in for k? And in for r? And 29 squared is 841, so this would be equal to 841. Because 29 squared is 841, and you have to put r squared in at the end. If you can't remember the distance formula, you all know the Pythagorean theorem. The distance formula derived from the Pythagorean theorem. Someone took a right triangle multiple times and put it on a graph and figured out that the length of the hypotenuse is always the 2 legs squared. So if you can create a right triangle using your radius, you can use your Pythagorean theorem. From C, which is way up at 8, and goes down to negative 13, this would be a length of 21. And X, which is at 5, and then goes back to negative 15, this would be a length of 20. 20 squared plus 41 squared, or 441 plus 21 squared, sorry, would equal your radius squared. So if you can't remember the distance formula, you can use your Pythagorean theorem. Got it? Cool, flip it over. Oh, wrong button. Below the 2 that we did, second to the bottom, it says write the standard equation of a circle with center 2, 3, and passes through the point negative 1, 1. It's just like the one we did, where you use the distance formula to find the radius. I'm going to show you the way that Andrew did it, and you don't have to remember the distance formula then. You can use the equation of a circle. X minus h quantity squared plus y minus k quantity squared equals r squared. H and k, remember, those are represent the center. X and y, those are just any points on the circle. So if it says it passes through negative 1, 1, that's an x and a y value on the circle. So if I take those red and blues and substitute them in, negative 1 minus 2 quantity squared plus 1 minus 3 quantity squared equals r squared. Now you have an equation where we're trying to get r by itself. And over here, you're just using your order of operations. Do what's on the inside first. Negative 1 minus 2. Negative 3 squared. One minus 3. Negative 2 squared. What's 9 plus 4? So r squared is 13, and which means r would be the square root of 13. So now you have your radius, and we already have the center given to us. So we're going to take those two things and plug them back into the equation. Because you won't ever be done when you find the radius. You're going to have to keep going to find the equation. So then x minus h, 2, quantity squared, plus y minus k, which is 3, quantity squared, equals r squared. Well, what did r squared equal? So it's just going to equal 13. So on your worksheet today, when you have to find the radius, you have 3 ways to do that. You can use the distance formula, you can use the equation of the circle, or you can graph it and use the Pythagorean theorem, find the right triangle there. Questions on that one? Okay, do the very last one then. Find the center and the radius of the given circle. What's the center going to be? 2, 3, good. Remember, in the equation, it's r squared. So what do we have to do with 27? Take the square root of it. If I wanted to break that down and make it the exact radius, then you would have 3 square root 3. If you wanted to round it, 5.2. Put 1. 5.2? Okay. Or well, yeah, either of those two since it doesn't say. Are we good on circles? Does it seem too complicated? I hope not.